Hello everyone. Today let's solve the problem number 2. Add two numbers, right? So you can just go through the question. You can just try to understand the question with the example that they have given. So I'll just summarize the question for you so that it will be easier to understand, right? So first thing is what the question states here. We are given two non-empty linked lists. You can clearly see here L1 and L2. So we are given two non-empty linked lists L1 and L2 that represents two non-negative integers. Inside this one we have certain elements in the array, right? Or certain elements in the list that is non-negative. The digits are stored in the reverse order. So here you can clearly see 564708. The digits are stored in the reverse order. That's what they have given here. Meaning one's place is the head of the list. The digits are stored in the reverse order, meaning the one's place is the head of the list. One's place is the head of the list that they have given here clearly. And each node contains a single digit. Each node consists of the single digit. This we know, right? What is our main task then? Our main task is to add the two numbers and return the sum as the linked list. So we have to add the two numbers and we have to what we have to do? We have to return the sum as the linked list also in the reverse order, right? That's what they have given here. We have to add the linked list and we have to return them in the reverse order. See here, you can clearly see 243 and 564708 here. The output will be here 807 because when you reverse this one, it will be 807. This one will be 342 and this one will be 465 and this will be 807, and finally when we reverse, the output that we get here is 708. That's what they have given. Same thing goes with example 2 and example 3 as well. You can check for them, right? So example 2 and example 3. So what shall we do here? Let's initially discuss the approach and let's dry run this one, example 1, right? So that we understand this one very clearly. And next thing is after the approach and dry running the example, let's go with the edge cases one by one, and then finally let's write the code and let's discuss the complexity of the code that we have written. So initially, as usual, we'll go with the approach. Let's discuss the approach. So the approach that we are going with here is iterative addition. So here, just remember the approach that we are going with here is iterative addition, right? So let's discuss the approach step by step. First thing is, let's start with the dummy node. While I say let's start with the dummy node, we have to create the dummy node as the start of the resultant linked list. So we are just creating the dummy node. Just remember this one. Why? It also simplifies the handling edge cases like empty list. We don't have to care for the edge cases like empty list. We are starting with the dummy node here, right? So first step will be start with dummy node here. Hope this is clear. So let's move on with the second step. Here, after starting with the dummy node, let's traverse both the list. We have two lists, right? One is L1 and one is L2. We have to traverse both lists. So I'll just give here traverse both lists here. This is fine. While I say traverse both lists, we will be making use of the while loop to traverse both linked lists until both are processed and there is no carry. This is important. We are making use of the while loop to traverse both linked lists. This is fair. This is fine until both are processed and there is no carry. This is important. This we have to keep in head until both the lists are processed and there is no carry. So this we have to keep in head, right? Let's move on with the third step. After traversing both lists, we have to add the digits. So let me give here. We have to add the digits. While I say we have to add the digits, at each step, we will be adding the corresponding digits of L1 and L2 along with the carry from the previous step. So we have to add the elements within the list, right? That's what we have to do. Finally, we have to return them in the reverse order. That's what we are doing here. While I say add the digits, we are at each step we are adding the corresponding digits of L1 and L2. L1 and L2 is nothing but lists, right? We have been given the two lists. At each step, we are adding the corresponding digits of L1 and L2 along with the carry from the previous step. This we have to keep in mind, along with the carry from the previous step. So this will be the third step. Let's move on to the fourth step. So in this step, we are updating the carry or update the carry. Let me give here update the carry here. This is fine. What we are doing here, if the sum is greater than or equal to 10, we have to update the carry for the next step. This is simple math, right? So addition. If the sum is greater than or equal to 10, we are just updating the carry for the next step, right? We are performing simple math here. Finally, last two steps are, after updating the carry, we have to create the new node here. Let me give here create a new node here. Let's discuss. While I say create a new node, I'm saying we have to append a new node with the value of some module, this one 10. While I say create a new node, I am speaking of appending the new node with the value of, appending means adding the new node. Append is nothing but adding a new node with the value of some module 10 to the resultant list. This is important thing. We are adding a new node with the value of some module 10 to the resultant list. That's what we are doing in the fifth step. The final step is we have to handle the extra carry as well. This is important thing. So after traversing both the lists, nothing but L1 and L2, if there is any carry remaining, we have to add it as a new node. That's what I meant when I said handle extra carry. So I'll just say this one in simple terms. Handle extra carry means it is nothing but after traversing both the lists L1 and L2. In our case, if there is any carry remaining, then we are adding it as a new node. That is what I meant when I said handle extra carry. So this is the approach that we are going with. So this is important. I hope the approach is completely clear. Next, let's dry run the first example that they have mentioned in the question, so that we understand this one clearly, and then let's move on with the discussing the edge cases one by one. So this is what the example one they have given in the question, right? So first thing we are considering here is L1. In the reverse order, it represents the number 3, 4 and 2. We can clearly see 2, 4, 3. In the reverse order, it represents 3, 4, 2. For L2, it represents 4, 6 and 5 here, right? So the output has to be here. While we add this one, we clearly know 5 plus 2 is nothing but 7. 807 in reverse order. We can just let me give this one correctly here. Just give me a second. 8, 0 and 7. While we reverse this, we have to get the output 708. So if we add this one here, 7, this has to be 6 plus 4 is nothing but 10. And here 4 plus 3 is 7 and 1 carry, and this will be 807. And while we reverse this one, 708. That's what we need to get the output here. So let's see this one step by step according to the approach that we have discussed. Initially, what we are doing here, we have to start with the dummy node to build the result list. Nothing but we have to initialize carry to the 0. First step is initialization. We are starting with the dummy node to build the result list, right? We have discussed this one. We are creating a dummy node, right? We have to start with the dummy node to build the result list. Initialize carry equals 0 initially. So carry will be 0 and initialize the pointers L1 and L2 to the heads of their respective list. So L1 where initialize this one to the head, we are initializing this one to the head as well. This is what we are doing in the first step. Let's move on with the second step here. So first iteration, we are adding the first digits of L1 and L2 along with the carry. So here sum we are considering 2 from L1. This is from L1 and plus 5 from L2 plus 5 from L2. So here you can clearly see, let me come here. 2 we are considering this one, 2 from L1 and 5 from L2, right? This is the first step, and 0 from carry. So plus 0 from carry. We do this is not equal to 10, right? 5 plus 2 will get 7. So this is 0 from carry. So the output will be here 7. We know this 5 plus 2 is nothing but 7. The output will be 7 here in this case. We are creating a node with the value 7 initially. So we got the output 7 here. What we'll do here, we are creating a new node with the value 7. And we are performing this operation here, 7 module 10 here, right? So update the carry equals 0 and 7 module 10. So we are moving the L1 and L2 pointers to the next node. Now the result list we have here is, I will just write here, the result list is 7 output and carry we have here is 0. Carry we have is 0. And the second step, let's move on with the third step. So this is the second iteration. So we have moved the first L1 and L2 pointer along with the carry. Now we are considering this one, these two, 4 and 6 here, right? So 4 from L1 and 6 from L2 and 0 from carry here. So let me come here. Sum equals, this is 4 from L1 and 6 from L2 and 0 from carry. So this will be 10, right? Now the output will be 10 here. We are creating a new node with the value 0. New node with the value 0. Why we are creating the new node with the value 0? Because we are performing the operation 10 module 10. Nothing but the remainder will be 0, right here. So we are creating a new node with the value 0 here. We are updating the carry 1 because here while we move to 10, we have to make use of the carry 1, right? So here the carry will be 1 because we are performing the operation here. This one, 10. This is fine. And we are moving the L1 and L2 pointers to the next nodes, right? We are moving the L1 and L2 pointers to the next node. Now the result list here is, in the third step, result list we have here is 7, the first one, previous one, we have got the 7, right? In the third one, we got 0 here. So it will be 7, 0. And carry we have made use of 1 here. In the previous step, carry was 0. In this step, carry is 1 here. So carry will be 1. I hope this is clear. Let's move on to the next iteration. Nothing but the third iteration, or this was the third step, right? We are moving to the third iteration and the fourth step. Third iteration, we have to process the 100 place or hundreds place here. So what we are doing here, this one, let's move to the first one. We are moving this one. We are considering this one, L1 3 and L2 4, right? Let me come here. L1 sum, let me consider here. L1 3, 3 from L1 and 4 from L2 here, and 1 carry, because previously we have the carry 1 here. You can clearly see here, this one or this one, carry 1, right? So 1 from carry. So this will be 7 plus 1 is nothing but 8. Now we have the output 8. We are just creating a new node with the value 8 here. because we are performing this operation. 8 module 10. We are creating a new node with the value 8. We are updating the carry. This time we are updating the carry with 0, right? We are just updating the carry with 0. We are performing this operation where we get the value 0. Now we are moving the L1 and L2 pointers to the null. So we don't have the next element, right? So that is the reason we are moving the L1 and L2 pointers to the null, nothing but the end of the list. So now we have the result. First one was in the previous step it was 7 0. Let's give this one 7 0, and finally in this step we got 8 here. It is 7 0 8, and carry in this step we are considering 0, right? This will be 7 0 and 8. Carry is 0, and we have to handle the remaining carry as well at the final step. In the approach we have discussed this one. We have to handle the remaining carry if present. So at this point we know that both L1 and L2 are fully traversed, completely traversed, and carry is 0. And since there is no carry left, we are stopping here and returning the result list. Nothing but result list we have here is 708. We are returning the final result list, nothing but 708 here. So the final output will be 708, which represents the sum 807 in the reverse order. So I'll just come here to the first one. So here we have to get this one in the reverse order, and we have to display the output 708. That's what we got here in the final step. I hope this one, the example what we discussed now is completely clear, right? So I'll be discussing the edge cases step by step. Each edge case you can dry run in this way itself. I'll not explain the entire step, this one, entire thing step by step. So you can just visualize in this way while I consider the edge cases one by one. So this is how we have to run the first example, run the example. So let's discuss the edge cases step by step next, and then let's write the code and discuss the complexity of the code that we have written. So here the edge cases, the first edge case is both the lists contain a single node with 0. So I'll just be going with L1, let me consider here 0, and L2, I'll just consider this one as 0 as well, because the edge case is nothing but it says both lists contain a single node with 0. The output is 0 as well here. Well, we know this one, right? So here this is for the condition both lists contain a single node with 0. So let's move on with the second edge case. I'll just come here. This is for the one list is longer than other. So while I say one list is longer than other, let me consider here L1 9 9 9. So L2, let's consider here 1. So the output will be here. Output will be 0 0 0 and 1 here. So how we got the output 0 0 0 and 1? You can visualize in the same thing, or you can just try run the example. I have shown the first example that they have given in the question, right? You can just try run in the similar way, or you can just visualize in the same way, right? So this is for the condition one list is longer than other. And the final edge case that we are going with here is this one. Both the lists have multiple carries. When both the lists have multiple carries, right? So let me consider the example. List 1 9 9 9 9, and L2 list 2 is having here 9 9 9 9. This is fine, and the output will be here. Output will be 8 9 9 0 0 1. This will be the output. So this is for the condition both lists have multiple carries. So I hope this is completely clear. These are the 3 edge cases that we need to keep in mind. First, this is for the both lists contain a single node with 0. We can clearly see here. And the second one is for one list is longer than other. You can clearly see here. This list consists of the 3 element. This list consists of only one element. This is for the edge case. One list is longer than other. And the third one or the final edge case was for both lists have multiple carries. You can clearly see here along with the output, right? These 3 edge cases that we have to keep in mind. Next, let's write the code, and I'll just discuss the code while writing the code itself, and then finally let's discuss the complexity of the complexities of the code that we have written. So as we had discussed, let's initialize the dummy node to the start to start the result list. So I'll just give here let dummy node equals new list node. This is fine. This is the first step. And the second step is we have to initialize the carry variable to store any overflow. So I'll just come here. Let me give let carry equals 0. This is the second step. And the third step is we have to create a pointer to traverse the result list. So I'll just give here let current equals dummy node here. So what we are doing here, we are just creating a pointer to traverse the this one result list in this step. So let's move on to the important step. The next step is we have to traverse both linked lists and we have to handle the carry. So we have discussed already this one in the approach. We can write in this way, right? We can just articulate this one in the form of code like this: L1 or L2 or carry. So I'll just come here. Let me give here this one. Let's add the current values of L1, L2 and carry. So I can just give here in this way. Carry equals carry plus L1 if present. So I'll just make use of this one, question mark symbol. If L1 if present, we are checking for the L1, right? So value of the L1 or 0. Plus same thing goes with the L2 as well here. Let me give here, let me copy paste this one and make the necessary changes here. This one will be L2. That's it. So after adding the current values of L1, L2 and carry, we have to create a new node with the digit. Nothing but carry module 10 that we saw while we dry run the example, right? So here we are creating a new node with the digit, nothing but carry module 10, and we have to link that one, right? So how can we articulate that one in the form of code? I'll just give here current dot next new list node of, I can just give here carry module 10. I hope this is clear. Next, this is simple step. Let's update the carry for the next iteration. I'll just give the carry equals math.floor, or we can just make use of double tilde operator in the place of math.floor. I'll just give here carry by 10. This one we saw while we dry run the example. So this is fine. Finally, after doing this, let's move the L1 and L2 to their next node. We have to carry on the same steps for the next nodes as well, right? If they exist. So we have to move the L1 and L2 to their next nodes if they exist. So I'll just give here L1 equals L1 if it exists next, or if it doesn't exist, let's initialize L1 to null. Same thing we'll be doing with L2 as well here. Let me make the necessary changes here. So I'll just give here L2. This one will be L2 darkness. This is same. This is fine. Finally, after this, what we'll do, we have to move the pointer of the result list. So this is simple. Nothing but current. We are moving this one to the current dot next. I hope this is clear. The final step is we have to return the head of the new list, nothing but next to the dummy node, right? How can we do that? Next to the dummy node, while I say we already have this one dummy node, right? So we can just return dummy node dot next here. Dummy node dot next here. This is fine. let me format the code and let me hit the run button. So here, oh, this has to be capital L, the line number 10, right? So let me make this capital L, list node. Let me hit the run button again. So you can clearly see the sample test cases are getting passed here. So let me hit the submit button. So you can clearly see all the test cases are getting passed here. So the code was absolutely correct. So let's quickly discuss the time complexity and the space complexity that we have for the code that we have written. So the approach that we went with here is iterative addition. You can clearly see here the approach that we went with here is iterative addition. So what will be the overall time complexity here? The overall time complexity would be big of n. Why here the overall time complexity here is big of n? Because we are traversing each list once. We are traversing each list once where n is the maximum length of L1 and L2, where n is the maximum length of L1 and L2. This one you can consider. So overall time complexity here would be big O of n here. Let me give here big O of n. So what will be the space complexity here? The space complexity would be big O of n as well. Why the overall space complexity here would be big O of n? Because we are making use of the space that is for the result linked list, which is directly proportional to the maximum of lengths of L1 and L2. Also, we are making use for this one, right? +1 for the carry. So, overall space complexity here would be big O of n. Again, I'm telling why the space complexity here is big O of n, because the space used for the result linked list, the space that we are making use for the result linked list is proportional to the maximum of the lengths of L1 and L2. And also we are making use of +1 for carry. Right? So that is the reason this one, the overall space complexity would be big of n here. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.